You've already seen that insoluble impurities are removed during a recrystallization by hot gravity filtration, where the boiling or near boiling hot liquid is gravity filtered through fluted filter paper, and if any precipitation occurs in the Erlenmeyer flask receiving vessel, the filtered solution need only be reheated to redissolve the precipitated solids with no need to add more solvent. Even so, why is it generally not recommended to use hot vacuum filtration instead of hot gravity filtration for this purpose? As you can see, when the boiling or near boiling hot liquid passes through the filter paper in the Buchner funnel into the filter flask, it immediately begins to reboil explosively and evaporate rapidly, causing immediate and complete precipitation of the dissolved solute, including any soluble impurities. The precipitated solids cover nearly the entire inner surface of the filter flask. This vigorous reboiling and the resulting violent evaporation is due to the lowering of the liquid's boiling point by the applied vacuum. At atmospheric pressure, 760 millimeters of mercury, the boiling point of water is near 100 degrees C, but under the applied vacuum, which is frequently less than 10 millimeters of mercury, the boiling point is closer to 10 degrees C, well below the temperature of the hot liquid you're pouring into the funnel. So the problems encountered by this approach include immediate precipitation of all dissolved solute, including the soluble impurities that you're trying to remove by slow selective recrystallization. Also, explosive precipitation causes solids to not only coat the inner surface of the filter flask, but to also exit the flask through the glass nozzle into the rubber tubing. The resulting situation makes it very difficult to collect all of the impure precipitated solids so that you can redissolve it in another portion of fresh solvent in order to purify it by recrystallization. Also, keep in mind that this demonstration used water as the recrystallization solvent, and water has a boiling point of 100 degrees C at atmospheric pressure. Recrystallizations are frequently performed using many other solvents with boiling points much lower than water's. For example, methanol, ethanol, ethyl acetate, petroleum ether, all are much more volatile than water, and hot vacuum filtration using any of those solvents would lead to an even more rapid evaporation under the applied vacuum, causing an even more violently explosive precipitation of dissolved solids. Consequently, in recrystallizations, insoluble impurities are normally removed from the hot recrystallization solution using gravity filtration and not by vacuum filtration.